Welcome to the Predictive Analytics for Marketing course. My name is Dr. Pahwa, and this is lesson 1 entitled Introduction to Predictive Analytics. So, in the previous two lessons, which is lesson 1.1, we answered this question, what is predictive analytics? And we also saw a lot of applications, especially in the marketing area, for predictive analytics. And then in the next lesson, we looked into the tools which are available to build the models for predictive analytics. Although these three tools are primarily used, Excel, R, and Python, but in this particular course, as I said before, we are going to primarily focus only on the Microsoft Excel. Now this is lesson 1.3, which is the predictive analytics modeling techniques. So we are just going to glance through all different techniques that are available to build the models. And we are going to primarily focus on the regression technique in this course. But we should know all different techniques. So we are going to glance through all different modeling techniques in this lesson. So this is the outline of this lesson. First, we are going to cover CRISP DM model. This is one of the methodologies that is being used to build a predictive analytics project. Then we are going to classify different modeling methods. There are total 11 modeling methods, and we are going to classify them based on the response variable, and you can classify them based on numerical or categorical variable as a response variable. We can also divide them based on supervised or unsupervised. And in the end, we are also going to look into the strategies. So we can use a strategy to classify these modeling methods. So the strategies are error-based, information-based, similarity-based, probability-based, or mimicking the human brain. So that is the outline of this lesson. So first, let us start with the CRISP DM model. And this is actually a methodology to do the modeling. And this is just a very high level procedure which should be followed to do any predictive analytics project. So the word CRISP DM basically stands for Cross Industry Standard Process for Data Mining. Now, this name was given in early 90s. So at that time, it was called data mining. But you can replace the word data mining or the last two letters of this word CRISP-DM. So the data mining can be replaced by machine learning or predictive analytics. It is the same thing. The reason we call this thing as data mining because these terms predictive analytics and machine learning were not very popular in 1990s, almost 20 years back. So this is the methodology or the procedure to do the predictive analytics project. So now let us go through this methodology. So we should start with the business understanding. So unless and until we have a very clear understanding of how the business is going to benefit from this project, we should not even start this project. So this is the place where things basically start, which is business understanding. Then after that, we have to look into the data and understand the semantics of data. And based on the data that is available to us, we may possibly modify or change our business understanding. So whatever we are trying to predict should be based on the data. Sometimes the data is not available to us, or we may possibly have to purchase the data from a third party. But whatever the case may be, during this process of CRISP DM methodology, we need to have a very clear understanding of what business is and what kind of data do we have. Now, the data that we are going to get is never very clean. Data, we have to also do a data preparation. It means that we have to clean the data, remove the missing values, or interpret those missing values, or whatever the case may be. 80% of the time is basically spent in this process. Once the data becomes clean, then we have to do the modeling, and that's what we are going to cover in this particular course, which is how to do the modeling. Once the model is done, then we have to do the evaluation, and after we have done the evaluation, we may possibly have to go back to business understanding, because the results that we were able to achieve is not good enough. It is quite possible that way. So we have to again modify our business understanding, again go through that particular loop. And this is the way it usually happens in the real world, that in the first iteration we never get the right results. So after a few iterations, once we are happy with the model, with the results that is being generated by the model, then we can deploy deploy that particular model in the real world. And of course, we are going to get some results after we deploy it, and and then you have to compare the results that we with our goals, and see whether our goals have been satisfied or not. And if not, then again we have to go through this cycle again and again. Usually in the first cycle, people don't get the very good results. So after a few iterations, then we have a very deep understanding of what we want to achieve, and what kind of data do we have. And again, we don't jump into the modeling part straight away. We cannot just say, okay, let's start the modeling. Before we do the modeling, we need to have a very clear understanding of how the business is going to benefit from this analysis. So this whole process is called CRISP-DM model, which is cross-industry standard process for data mining. So the CRISP-DM process model has 6 steps, which are enumerated them in the previous slide, but let us go through one more time. In the step 1, we start with the business understanding of what you want to do with the data mining. Step 2 is data understanding, interaction between business understanding and data understanding. Step 3 is data prep. Here, there has to be some interactions between data preparation and modeling part. And then we start doing the modeling. And then we have to do the assessment of the model. And at that time also, we may have to have some interactions between the model evaluation and business understanding. Then we deploy the model. And then results achieved from predictive analytics should be compared with the business understanding or the business goals. And if we are, again, in the first iteration, as I said before, we may not able to get 100% what we want. So we may possibly have to modify our business understanding or the goals, and repeat this process. And again, this cycle just goes on and on and on. You're never going to achieve the perfect results, but you will come close to perfection after every iteration. So that is the process. This process is called CRISP-DM, and it is very strongly recommended that we should follow this CRISP-DM model in order to get good results. So in this course, we are going to basically only going to discuss the model building strategy. So model building strategy, which is of step 4, can again be split into 4 parts, which is selection of the modeling technique, and then generate the test design, build a model, and do the assessment. So, and that's what this course is all about. But before you start doing any real world project, you have to go through those 6 steps. But in this course, we are only going to elaborate on step number 4. So now let us look into the common modeling methods which are available to us. There are 11 of them, and so we are going to enumerate them. And after that, we are going to classify these 11 models using different criteria. So these are these 11 modeling methods. So let me enumerate them: linear and polynomial regression, logistic regression, discriminant analysis, k-nearest neighbor, decision and regression trees, naive Bayes, neural network, clustering, principal component analysis, support vector machines, and ARIMA. This is used for time series. And ARIMA stands for autoregressive integrated moving average. These are the 11 methods, and the last one that was invented was a support vector machine that was in early 1990s. So it is very difficult to invent a new learning method, and in future we may possibly see some more, but it is not easy to come up with a new method. But so far these are the 11 methods that we have, and we are going to study quite a lot of them in this particular course. So since we have 11 predictive analytics techniques or machine learning techniques, which one is the best? So why do we consider so many different techniques? So which one is the best? So somebody may ask this question is that why can't we just select one of them, which is the best one, and stick with that and throw away all the remaining 10? And the reason we cannot do that thing, because no one technique is the best. It's all depends upon your data. So some techniques may work better on certain type of data, and also some techniques will going to work better for certain type of applications. So we have to study all of them, and we have to understand what is the basic difference between them. And not only we study from a high level, but we have to understand the basic mathematics which is behind these techniques. And then we have a very clear understanding of why this technique is used, what are the good features of this particular technique, and which type of data on which it is going to work best. So with this deep understanding, we can do machine learning. So now let us look into the goals of a predictive analytics application. So there are two different type of goals. One is estimation, other one is classification. So estimation basically means that we are predicting a number. It means, and this is usually the output of a regression. So it could be like a price of a house, product sales, gross national product, employment number, or whatever the case may be. But the output is a numerical number. Then the other type of goals that we can have in a predictive analytics application is the classification. So in the classification, what we are outputting is a variable which is of type categorical. So it means it may have few levels, like sports team is going to win or lose, email is a junk or not, which grade students is going to get, the tweet is positive or negative. So here the output is a categorical variable. So that is the basic difference between different modeling methods. Some of the modeling methods like regression is very good for outputting a number, whereas another modeling methods like naive based decision trees and a few other ones also, they only generate a categorical variable. So that is the way by which we can split the goals of a predictive analytics application. So either it could be estimation or classification. So we have seen 11 different modeling methods. So now we are going to classify them into different categories. So that's what you're going to cover next. So out of those 11 modeling methods, we can classify them based on the response variable. So the output could be numerical or categorical, or they can be supervised or unsupervised, or different, what kind of a strategies do they use? So the strategies could be error-based, similarity-based, information-based, or the probability-based, or mimicking the human brain. So now let us divide those 11 modeling methods into different categories based on the criteria. So we are going to study basically three different criterias: response variable, supervised or unsupervised, or the strategy. So now let us look into the response variable. So how can we categorize different modeling method based on the response variable? So as we discussed before, the response variable can be numerical or it can be categorical. So let's now divide our modeling methods based on the response variable. So if your response variable is numerical, then the best way to solve that problem is to use regression. So we are going to study regression in quite detail. So we can do linear or polynomial regression. Neural networks can be used for both, for categorical or for numerical. And ARIMA, which is a time series, is also used for predicting the response variable, which is numerical. Now, if your response variable is categorical, then you can use logistic regression, but logistic regression is only used for binary categorical variable. It means my categorical variable has only two states, either 0 and 1, or the stream is going to win or not going to win. But if you have more than one levels of your categorical variable, then logistic regression cannot be used. So for that, we can use discriminant analysis, k-nearest neighbor, decision and regression trees, and also naive Bayes. And neural network, as I said, is used for both numerical and categorical. Now, support vector machines are also used for categorical. These two remaining ones, which are clustering and principal component analysis, are unsupervised learning methods where we don't have a response variable. So clustering and principal component analysis, this issue is not even applicable. So this is the way by which we can categorize our modeling method based on the response variable. The next strategy that we can use to classify our modeling methods is called supervised or unsupervised learning. So now let us look into supervised and unsupervised learning. So in a supervised learning method, we have a target variable or a response variable. Whereas unsupervised learning method, we do not have a target variable. So that is the only thing that is different between supervised and unsupervised learning. So the target variable or the response variable is called a supervisor. So the supervisor basically teaches how to build the model. Whereas in unsupervised learning method, there is no target variable. So the unsupervised learning methods are clustering and also principal component analysis. And that we are going to see in the next slide, that how we can divide our learning methods into supervised and unsupervised methods. So the unsupervised learning methods are only two, but rest of them are supervised. So supervised learning is very common compared to the unsupervised learning. So in the case of a supervised learning, we build a model by splitting the data into two parts. We have a training data and the testing data. And using the training data, we build a model. And once the model is ready, then to see how good the model is, we use the testing data for that. Because for the testing data, we already know what the value of the response variable is. So now, using our model, we can do the prediction, and then using the testing data, we can check if the predictions came out to be right or not. So that is the way we do the model assessment. So most of the modeling methods are supervised. The unsupervised modeling methods are clustering and principal component analysis. So these are two special kinds of modeling methods, but rest of them are all supervised learning methods. Now let us look into classifying the modeling methods based on the strategy to build a model. So we use different type of strategies to build a model, and these strategies are error-based, similarity-based, information-based, probability-based, and mimicking the human brain. Under error-based learning, we have regression, which is linear regression, and a multivariable regression, and also support vector machine. These two modeling methods use error-based learning. Then the similarity-based learning strategy is being used by k-nearest neighbor. Then information-based learning is being used by decision trees, decision and also regression trees. Then we have the probability-based learning, which is used by naive Bayes, and in the end we have mimicking the human brain strategy, which is used by neural networks. So now let us look into a little bit more detail in each of these strategies that is being used to build a model. So first of all, let us look into the error-based learning. So in this method, we compute the error, and then we try to minimize that error. So we are going to suggest a model. A model in a case of a regression is just a straight line if it is a linear regression. Then we are going to compute the error, that how much off we are from our goal, and then we try to minimize that error. And this strategy has been used by linear multivariable regression and also by support vector machines. So in the error-based learning, we take the training data, set the parameters value, and compute the total error. And then we keep on changing the parameters till we minimize the error. So that is the basic strategy. So we start with some arbitrary parameters, and then we try to minimize it. And this process is called the gradient descent algorithm. Or we can also, in fact, for regression, we also have a closed form solution as well, which uses a matrix. But if we use the gradient descent algorithm, then that's what basically the strategy is, that we try to minimize the error. In fact, this particular strategy of error-based learning is a strategy that all humans use to learn something. As you recall that when we were learning to ride a bike, we sit on a bike and sometimes we fell down, so that is an error. And from there we learn something and then we try to improve it. So this is the most natural form of learning. And as we all know, we have heard this particular proverb which says that mistake is the best teacher. And also another quote from Eleanor Roosevelt, learn from the mistakes of others. You can't live long enough to make them all by yourself. So that is the most natural form of learning, and machine basically learns from this strategy. So there are two techniques, or there are two modeling methods that use this technique. Where one is the linear multivariable regression and also support vector machine. And later on, we are going to cover these modeling methods in a lot more detail. Now, the next strategy is called similarity-based learning, and the modeling method that uses this similarity-based learning is called k-nearest neighbor. And we are going to cover this modeling method in quite detail later on. In the similarity-based learning, the basic strategy is this. We are looking for a neighbors of certain objects, and if an object belongs or that particular object has certain characteristics that is similar to the objects which are there in our data set, then we say that that particular object or this new object belongs to that particular set of observations that we have. So basically the idea is very, very simple, that if it looks like a duck, walks like a duck, and quacks like a duck, then it must be a duck. So that is the basic idea that is being used. In fact, if you even, in fact, this particular strategy is being used by infants as well. If you have a toddler or 5 years old kid, and if the toddler has certain toys and asks the toddler to arrange these toys, that very likely that toddler may put all the red toys in one bin, blue toys in another bin, and green toys in another bin. So that's a simple strategy. We don't even have to teach this particular strategy to the kids, and it comes in a natural form. So that is the strategy that is being used for k-nearest neighbor. So in the k-nearest neighbor, we are going to compute the distances between the objects. Here we can either compute the Manhattan distance or the Euclidean distance. So that's in fact the mathematics of the k-nearest neighbor is very, very simple. And once we can compute the distances, we can sort those distances, and the nearest ones are the ones that we are going to classify. So that particular objects belong to that particular group or subset of the observations. Here we can measure the Euclidean distance or the Manhattan distance. Euclidean, of course, is xi minus yi whole square, sum of all of that. And in the case of a Manhattan, we compute the absolute values of the difference in x and y. And we are going to cover this in a lot more detail later on. Now, the next strategy that we use is information based, and here we build trees, so decision trees and regression trees are the ones that are built upon information based learning. Now, in the information-based learning, we ask questions, and based on the answer that we get, we can do the prediction. So this particular approach was also being used by Socrates almost 2,500 years back. His style of teaching was that he used to ask his students to ask him questions. And based on the questions which have been asked, people used to learn that material. So, in fact, Socrates, who lived almost 2,500 years back, believed that disciplined practice of thoughtful questioning enabled the students to examine the ideas logically and to determine the validity of those ideas. So that is the strategy that is being used. We'll start asking questions, and based on the answer, that we're going to learn something. So Socrates was a Greek philosopher, so he lived up to the age of 71. Then he was asked to drink a cup of poison, and so he was actually executed by the society at that particular time. Well, that was a very unfortunate thing. But anyway, this is his style, and in fact, his style of teaching became so popular and it was so potent that it is still being used. So that is the very, very brief bio of Socrates. So now the question is that what is a decision tree? So decision tree is similar to the 20 questions. There is a game that is being played by kids in which there are certain objects from which one kid is going to select some object, and other person who's playing against has to guess what that particular kid has chosen. So you're going to ask 20 questions, and based on the answers of those 20 questions, someone is no, they have to guess what that particular object is. So this is just a kid's game, but the basic philosophy or the strategy to build decision trees is identical to the strategy that is being used by 20 questions. So there are also some proverbs that we can see where that we hear all the time, that knowledge is having the right answer, intelligence is asking the right question. So, and also, I never learn anything talking. I only learn things when I ask questions. So these are very famous words that has been, they're said by big philosophers, and that thing is true, and that exactly the strategy that we use when we build decision trees. So now let us take an example of a decision tree. Suppose if I've been given this data in which I have the gender, car ownership, travel cost, and income level. And my response variable in this case is transportation mode. And so based on this data, I can build this tree. Now, how to build this tree is something that we are going to cover much later. But that is the idea behind a tree. So once the tree is done, and if we get some new data, then based on these variables, we can do the prediction. So here, if the travel cost is expensive, we go on this direction, or if it is standard or cheap, we ask the second question: what is the gender of the person? Male or female, these are two possible answers, and if the car ownership is 0 and 1. So based on that, we can do the prediction. Now, building this tree is not that simple, it's not that easy. We are going to talk about entropy of the tables, and a lot of mathematics gets involved when we build the decision tree. But the idea here is this, that we, at every step of the tree, we are asking questions, and based on the answers that we get, we are going to follow this particular tree and basically do the prediction. So the modeling method that uses this particular strategy is called decision trees and also called regression trees. If the variables that we are dealing with are categorical, then it becomes a decision tree. And if the variables that we are dealing with are numerical, then it becomes a regression tree. So we are going to discuss this decision trees and regression trees in lot more detail later on. And the split of a decision tree are actually based on the entropy of the tables. So we are going to define a concept called entropy. And once we know the entropy of our tables, based on that, we can split these trees and finally build a decision tree. The next strategy that we use is called probability-based learning. Here we are computing the probability, and we use the Bayes theorem for computing the probability. And the learning method that uses this strategy is called naive Bayes. So naive Bayes strategy was being invented by Thomas Bayes. Thomas Bayes lived in 1750s, which is almost 25 years before America got independence. And his famous formula is probability of A given B is equal to probability of B given A multiplied by the probability of A divided by the probability of B. So this is a very, very famous formula invented by Thomas Bayes, and this formula is used to build our model. So Bayes rule basically allows us to compute the reverse probability, or which is also called the posterior probability. So now if we are given the probability of B given A, then how can I compute the probability of A given B? So this is a very famous formula, which is probability of A given B is equal to the probability of B given A multiplied by the probability of A divided by the probability of B. So this is the foundation on which this particular model is being built. So now the question is that why it is called naive Bayes. The naive Bayes is because we make a very naive assumption that our variables are independent. So, which is not the case. Even if we don't know whether our variables are independent or not, we make that assumption and compute the number. So we do actually incorrect mathematics here. But even if we make that mistake, the results that we get are very, very good and are very effective. So that is the reason why we make this assumption. So now, for example, if want to compute what is the probability that a person will respond given that the customer is urban and golfer. So here we will assume that the customer is urban is independent of if the customer is golfer. And we may not, it may not be true. It may, we don't, since we don't know that, we just make this assumption and make our mathematics very easy to solve the problem. So by solving the problem, we usually get very good results, even if we know that the basic assumption is wrong. So that is why this method is called naive assumptions. Naive has nothing to do with Mr. Bayes. Mr. Bayes was a very smart guy. And we just make this naive assumption to solve our mathematics. And it is also a very, very effective and very popular learning method. And just because we make these naive assumption, this modeling method is called naive Bayes. Now, the last learning method we are going to cover would be neural networks. And neural networks are based on the idea that neural networks mimic the human brain. They are similar to human brain, how the human brain works. So, based on that strategy, we build neural networks. So the inspiration of neural networks comes from human brain. By studying the human brain, biologists have said that human brains have approximately 86 billion neurons. And these neurons basically take the input from other neurons, and then after that they fire. Fire means that they were going to generate an output based on what the values of or what these signals are which a one particular neuron is receiving. And if under certain condition these neurons are going to fire, it means these neurons are going to send another signal to some other neurons. So that is the way human brain works, although we still don't understand the human brain completely. But up to a certain extent, we understand it, and that's what basically goes on in human brain. So based on this strategy, they are starting building neural networks, and neural networks have been proven to be very, very effective of solving certain type of problems. So neural networks behave similar to human brains. The central idea is that we extract linear combination of input, and based on the values and the weights for every input, it may choose to fire or it may choose not to fire. So that is the idea behind neural networks, and neural networks are very effective in solving the human vision problem. So in neural networks, we can build a simple neural network in which we have only one hidden layer. So you are looking at the neural networks here in this diagram. So these red nodes are the input nodes. And then the hidden layers is yellow nodes, and output layer, of course, is these blue nodes. So all input layer neurons are connected with all the intermediate, and all the intermediate are connected to the output layer. So this is just a simple neural network. Now you can increase the number of hidden layers from 1 to 4, that has been shown here in the diagram. But in the real world, there is no limit to the number of hidden layers. You can, all the number of hidden layers which are there in an image recognition neural network. We can have as many as 150. And so we have now billions of these neurons which are being simulated in a neural network. And once we have a very deep learning neural network, then it becomes very, very effective. The deep learning basically means that it has lots and lots of these hidden layers in between our input layer and the output layer. So this process is called deep learning. So the main application of neural networks is image recognition, image classification, handwriting identification, and speech recognition, and a few more. So neural networks are not used for very simple problems, because for simple problems in which we are trying to predict something, some numerical values, we can have many other models that can do the job. Neural networks are only used for very complex problems which other models cannot solve. So this image recognition, image classification problems are very, very complex enough that other models cannot solve them. In fact, deep learning neural networks are used in autonomous cars, where a camera has the ability now to recognize all the objects which are coming in front of the car, so that it can drive all by itself. So this is a very, very complex problem. So to solve very, very complex problem, we use neural networks. Neural networks are not used to solve very, very simple problems because there are other models out there that can do the job. So now let us look into all the 11 models that we talked about, that what kind of a strategy they use. So for linear and polynomial regression, it is error based. So we are trying to minimize the error. Whereas in logistic regression, we are trying to maximize the likelihood. We don't minimize the error there, but we maximize the likelihood. Then for k nearest neighbor, of course, we use the similarity based. Decision and regression trees are based on information. Naive Bayes is based on probability. Neural networks are based on mimicking the human brain. And support vector machines are based again on error based. And ARIMA, which is for time series, we use auto regression and moving average. So these are different strategies that are being used to build different type of models. So that is the end of this lesson. Here, let me summarize what we covered. We first covered the CRISP DM model. That is just a procedure or very high level methodology to do this predictive analytics project. Then we looked into different modeling methods and we divided these modeling methods based on response variable or based on whether they are supervised or unsupervised or what kind of a strategy do they use. So there are many different strategies that have been used: error-based, information-based, similarity-based, probability-based, and also mimicking the human brain. So these are different strategies that has been used to build these models. And we are going to cover most of these models in a lot more detail later on.